Hello, scholars. We are going over Chapter 4, as you know, in Algebra 2. And I have some more notes and examples that I've put in the notebook. But if you're quarantining or if you're not here for whatever reason, I'm going to be going over these notes in this video so that you can hopefully stay with us as a class. So far we've been doing multiplying, dividing, adding, subtracting polynomials, and that was after we looked at some graphical solutions. Now what we're going to do is we're going to factor these polynomials. So that's the whole point in what we've been doing. And when I say factor completely, that usually means more than one step. Okay, so if you want to follow along in your book, there's 4 pages right here. And basically what it means is once you take a polynomial, if you can write it as a product of unfactorable polynomials, usually like a greatest common factor or a binomial, then you're done. So the point is to get it factored all the way. Nothing can be left. And we have a factor theorem that says that any polynomial, this function f of x, has a factor x minus k like a binomial if and only if that factor gives you a remainder of 0. So this is the definition of a factor. The numbers will go into bigger numbers evenly, or the binomial will divide into the polynomial evenly. This is a special case of the remainder theorem we went over last week. Now, just so you know, this theorem is a special case of that remainder theorem that we went over in 4.3. So there's actually a number of different cases here, and you may ask yourself, how do I know how to factor? Well, look at how many terms you have. And in general, I'm going to give you some hints. I'll probably do 3 little separate videos here. But if you have 2 terms, there are certain things to look for. If you have 3 terms, that's the one you're mostly familiar with, how to factor a polynomial. And then if you have 4 terms or plus, because it can work for more, I'm going to be showing you how to do that in, again, a separate video called Factoring by Grouping. So first of all, if there's only 2 terms, well, you can either find a greatest common factor, which you've been doing for years and years. We'll do some examples. Or it might be a special pattern, and there's 5 of them we're going to go over. First of all, the sum and the difference pattern, which you should recognize, and if you don't, that's okay, we'll review. This is on your student journal, page 83, if you want to add notes to that. So if you recognize 2 terms, it could be a sum and difference, it could be a square of a binomial, or a plus or a minus. It will follow this pattern with these examples. It could also be a cube of a binomial, which this chapter, of course, we're going over cubes. So again, I'm going to be doing some of these other examples in a separate video. This is just an overview of the notes. The 2 other special patterns you would look at for 2 terms is the sum of 2 cubes, which would be something like a cubed plus b cubed, or the difference of 2 cubes. And they both are very similar patterns. They're almost exactly the same. Okay, so those are the 5 ways. Again, we'll go over each one separately. If you want to see where these 2 special factoring patterns are, they're in your student journal on page 93. So if you don't want to write this down, just go ahead and take those notes from right there. Now, overview. If you have 3 terms, remember there's a number of different ways to factor. We learned all kinds of different ways. If you don't remember, we will review them. Basically, it's the opposite of FOIL. Remember, FOIL is first, outside, inside, last, if we're multiplying 2 binomials. Now, if it's not prime, then you'll have 3 terms, and those 3 terms will factor into 2 binomials, where the first 2 terms multiply to give you the first term, and the last 2 multiply to give you the third term in the trinomial. The outside and inside will multiply to combine into the middle term. So x squared comes from here, x times x. 10 comes from here, 5 times 2, and 7x comes from 2x plus 5x. Similarly, here's a second example with a few more coefficients, but 3x times 2x gives you 6x squared. Negative 20 came from the plus 4 times the minus 5. And then when you do plus 8x minus 15x, you combine to get negative 7x. That is if you have 3 terms. Now, if you have 4 terms, again, I'm going to do a separate video for this. But it's called factoring by grouping. And what you do is you take pairs of terms that have a common monomial factor. We're going to spend a whole day on this in class with a separate worksheet. It's already in the notebook if you want to see it. The pattern for grouping is shown here. Okay. Basically, you can group them by whatever they have in common. And when you take out those common factors, it will often result in a common factor you can rewrite as the product of 2 polynomials. So if you have an RA plus an RB, then they have an R in common. If you have also SA and SB, they have an S in common. So when you take out the R, you could group it like this, RA plus RB and SA plus SB. So hopefully you can see that since they're both multiplied times A plus B, then that R plus S can come together as a separate binomial. So that's an overview of 4.4. Sometimes you'll have to do more than one step, but this is a big section because you'll have to recognize the special patterns, and you'll also have to do it multiple times, factoring completely. So I'm going to go on to a separate video.